Hello everyone. My name is Dr. Poonam Agrawal. I am Associate Professor at Department of Applied Sciences and Humanities at ABES Engineering College, Ghaziabad. So in continuation to the previous part of chi-square test, where we got a glimpse of the introduction part of chi-square test along with the method and steps of chi-square test, we are going to take a step further and we are going to understand how chi-square test is applied as a goodness of fit. So in this video lecture, we are going to go through the introductory part of chi-square test. After that, we will understand the application part of chi-square test as a test of goodness of fit. And then we will have a better understanding of this concept with the help of a few examples. So this is the notation that we use for chi-square test, which is a Greek letter. Chi-square test is a statistical tool which was given in 1900 by the mathematician Carl Pearson for the purpose of comparing observed distribution of data with expected distribution of data. So chi-square test proves to be a very good choice for the understanding and interpretation of the relation between two categorical variables in a better way. So for the purpose of applying chi-square test as a test of goodness of fit, the steps are going to remain same. The things that we need to understand is, first, chi-square test as a goodness of fit is applied to determine how well a probability distribution such as binomial probability distribution, Poisson distribution, normal distribution, etc. fit the experimental results. We also have to keep in mind that for binomial probability distribution, the degree of freedom is considered to be n minus 1. For Poisson distribution, it is taken as n minus 2. Whereas for normal distribution, the degree of freedom is n minus 3. Rest of the steps are going to remain same along with the formula. Just for revision purpose, we are going to revise the formula again. So chi-square statistics is calculated by the formula summation OI minus EI whole square upon EI, where OI is data for observed frequency in various categories and EI is expected frequency distribution of data or theoretical distribution of data into same categories. So let us have a look at the tabulated table of chi-square test. This is the table that we use for finding chi-square tabulated, which is calculated at alpha degree of freedom and for alpha level of significance and beta degree of freedom. In general, the degree level of significance is considered to be 5% or 0.05. For degree of freedom, we look at the first column of this table and the intersection point of desired degree of freedom and desired value of level of significance gives us the required value of chi-square tabulated. Now let us move towards the examples of chi-square test where we verify this, use this test for goodness of fit. As the first example, we are going to consider the records collected for number of male and female births in 800 randomly selected families having 4 children each. When the data was selected randomly, it was observed that out of 800, 32 families were there which had 0 male children and 4 female children. 178 families were found to have 1 male child and 3 female children, and so on. Now, using this data, we have to verify whether the data are consistent with the hypothesis that the binomial law holds. So we have to verify whether the theory says that the data distribution should be according to binomial law, and this is observed frequency. We have to see whether observed frequency and theoretical distribution of data match to each other or not. When it is given that the chance of male birth is equal to the chance of female birth. All right. So for this purpose, first of all, we have to declare null hypothesis H naught. We always assume in null hypothesis that both theoretical distribution and observed data distribution match with each other. So we can declare that theory is supported by observation, or we can say that data follows binomial distribution, whereas H1 will be negation of H naught, that is theory is not supported by observation, or data distribution does not follow binomial law. Okay. Next, alpha, that is level of significance. Since it is not mentioned in the question, in general we take it as 0.05, which is 5%. Next is beta, that is degree of freedom. Since we are going to verify binomial law, it will be equal to n minus 1, where n is number of categories. Now see, how many categories do we have? We have 5 categories in which data distribution is given to us. Let us mark these categories as category 1, 2, 3, 4, 5. Therefore, the observed frequencies will be O1, O2, O3, O4, O5. All right. So n is equal to 5, and hence this value will be 5 minus 1 equals to 4. Now we have to apply chi-square test, for which we will need values of OI and values of EI. Values of OI are already given to us, and we have to calculate values of EI. EI, expected frequency. So for first category, expected frequency E1 is out of 800 families. How many families are there in which out of 4, 0 children are male, where probability of male child and female child are equal? That is, probability for a child to be male is half. So this will be equal to 800 into 4C0. Out of 4, 0 are male, where probability of male child is half. So half raised to the power 0 into half raised to the power 4 minus 0, which is equal to 4. So when you solve this equation, you get this value is equal to 50. Next, E2 is the second category, where we have to find out of 800 how many families are expected to have 1 male out of 4 female children. So this value will be equal to 4C1 half raised to the power 1 half raised to the power 4 minus 1, that is 3, and when you solve it, this value comes out as equal to 200. Similarly, we can calculate E3, E4, E5 using the same formula, and these values will come out as equal to 300. E4 will be equal to 200, same as E2, and E5 will be equal to 50. So according to binomial law, the data distribution in these 5 categories should be equal to 50, 200, 300, 200, and 50. Now, for calculation of chi-square statistics, we can make a table for OI, EI, and for OI minus EI whole square upon EI, where OI will be observed frequency, and as per given in the question, the values were 132, 178, 290, 236, and 64. And EI, these values we just calculated as 50, 200, 300, 200, and 50. Right? And you can always verify that sum of OI is always equal to sum of EI, and it has to be. This is the basic condition for application of chi-square test, which was also told in part 1. Now we have to find OI minus EI whole square upon EI. So first value will be 32 minus 50 whole square upon 50. And when you solve it, this value will be equal to 6.48, 2.42, 0.333, 6.48 again, and 3.98. And when you add these values, you get it equal to 19.633. And why do we add these values? Because chi-square statistics is equal to summation of OI minus EI whole square upon EI, right? That is 19.633. So this is what we get as chi-square statistics. Next, we have to find chi-square tabulated, which will be found at chi-square alpha, that is 0.05, comma chi-square beta, that is 5 minus 1 equals to 4. And you can see from the table that at 0.05 level of significance and at 4 degree of freedom, value of chi-square tabulated is 9.488. So let us write this value as 9.488. Now chi-square tabulated is 9.488 and chi-square tabulated is 19.633. So obviously chi-square statistical value is greater than chi-square tabulated, and therefore the conclusion that we draw is H1 accepted. That is, the data are not consistent with the hypothesis. Data are not consistent with the hypothesis that binomial law holds. Okay, data is not in agreement with binomial law, right? So this way we have verified whether binomial law fits well to the given data or not. As the next example, in this case, we are going to verify whether data are consistent with Poisson distribution or not. When it was observed that 392 pages in a book, in 392 pages of a book, which in total had 1200 pages, it was observed that 275 pages were there which had zero printing mistakes, 72 pages were there which had one printing mistake each, 32 pages were there which had two printing mistakes each, 7 pages were there which had three printing mistakes each, and so on. In total, how many categories are there? 3, 4, 5, 6, 7. So 7 categories are there. We have to find whether this data distribution of printing mistakes is supported by Poisson distribution or not, when the level of significance has to be taken as 5%, right? So for this purpose, first we have to apply Poisson distribution, right? We have to verify Poisson distribution. So for this purpose, first we declare null hypothesis, that is data is supported by, data are consistent with Poisson distribution. Data are consistent with Poisson distribution, whereas H1 will be against H0, that is data are not consistent with Poisson distribution. Alpha level of significance is given as 0.055. As of now, beta, that is degree of freedom, is n minus 2 is equal to 7 minus 2 equals to 5 as of now, right? Now, OI observed frequency is given to us into 7 categories, and we have to find EI, that is E1. E1, E2, E3, E4, E5, E6, E7, right? So E1, that is expected number of pages having zero printing mistake. So how are we going to find it out? Look carefully. N into P1. How many pages are there under study? 375, not 1200, right? Into P1. Now, how are we going to find P1? Look carefully. P1 will be obtained by Poisson distribution. Formula for Poisson distribution is PR equals to e raised to the power minus lambda into lambda raised to the power r upon factorial r, right? So when r equals to 1, we can put r equals to 1. The only problem is in finding lambda. Now remember, lambda is mean, which can either be calculated by NP, or when data distribution is given, it is calculated by summation fx upon summation f. And look here, in this data, x and f are given, and therefore we can find summation fx upon summation f from this table, which will come out as summation fx 189 upon summation f, that is 392, and this value will be equal to 0.4821. Hence, P1 will be equal to e raised to the power minus 0.4821 into 0.4821 raised to the power 1 upon factorial 1, right? And therefore, E1 or E1 will be equal to 375. I just forgot to write it. 375 into P1. And when you solve this value, you get it equal to 242.1. So this is how we can find E1, right? Similarly, we can find E2, E3, E4, E5, E6, and E7. So when we find these values, we get them equal to E2 equals to 116.69, E3 equals to 28.13. Now you can see that the values are dropping very fast. 4.52, E4 has become less than 5. E5 equals to 0.54, E6 will come out as 0.052, and E7 will be equal to 0.0042. Now look carefully. Now we just have to make the table for OI and EI, right? So OI values for OI were 275, 72, 37, 5, 2, 1. 7 categories including purchase. And there here the values are 242.1, 116.69 or 7. Let us round it off to the first decimal place. 28.1, 4.5, 0.5, 0.10. All right. Now, in the first part, I told you that when expected frequencies are less than 5, they are supposed to be clubbed so that the value of the expected frequency is always greater than or equal to 5. So we combine these values and we get this value as equal to 5.1. And simultaneously, we combine these values also so that 7 plus 5, 12, plus 2, 14, plus 1, 15. These values become 15. So now the problem becomes, first category is for number of pages having 0 printing mistakes. Then second category for number of pages having 1 mistake. Then third category for number of pages having 2 mistakes. And fourth category for number of pages having more than 2 mistakes. So in total now we have 4 categories, right? Next we find OI minus EI whole square by EI. So first entry will be 275 minus 242.1 whole square divided by 242.1, and this will be equal to 4.471. Next entry will be 17.121. Then we will have 0.128. And the fourth entry will be 15 minus 5.1 whole square upon 5.1, which is 19.217. And when we add them, this comes out as 40.937. All right. So we have found chi-square statistics as equal to 40.937. Next, we have to look at the table for finding chi-square tabular, that is chi-square at level of significance 0.05 and degree of freedom equals to 4 minus 2, that is 2, right? Since now there are only 4 categories, and for Poisson distribution the number of the degree of freedom is n minus 2, right? So let us look at the table to find out the value at 0.015 at 0.05 level of significance and degree of freedom 2, and the value is 5.991. So this value comes out as 5.991, and therefore chi-square statistics is obviously greater than chi-square tabulated, and therefore data are not supported by Poisson distribution H1 accepted, or data are not consistent with Poisson distribution. So this was all about binomial distribution and Poisson distribution, or to summarize, it was about chi-square test as a test of goodness of fit. So that is all for this video lecture. In the next part, we will understand chi-square test as a test of independence. Thank you, everyone.